Hey, it's Paul here. So welcome to day one. If you haven't looked at day 0 yet, then please go back and look at that. It explains how the course works. If you've got any comments, because I'm adding these sequentially, I'll get to see your comments on day one and be able to adjust moving forward. So if you see all 60 days uploaded, then obviously it's a bit too late for me to start introducing changes. But because you're looking at day one, I can start doing it now. So the only thing I wanted to mention is, if I can get the next slide up. Oh yeah, so I might do this every day. Drop a comment if you want me to. I'm going to explain what you're going to learn today. So today you can see on the left there it says number 1. That refers to day 1. You can ignore some of the other stuff. The only other thing to look at is the iOS command navigation. So most days have a lab or 2 labs or 3 labs attached. So there'll be a lab today, and it looks like it's the iOS command navigation. You need to grab a copy of Packet Tracer, free from Cisco systems, so just Google Packet Tracer or use a live rack or your home rack if you've got it. So we're going to look at network devices, OSI model, TCP, cables, CSMA, CD. Now in the lesson you'll hear me refer to the old versions of the exam, for example ICND1, ICND2. Don't worry, because a lot of the stuff is being brought forward to the current version of the exam. So this is current as of 2022. I don't have the exam code, I think it's 301, but it is current. But I decided not to take off the old references because it meant editing all the videos. The only other thing before we get started, the book to match this video course is on Amazon, link in the description. It's Cisco CCNA in 60 days. So this basically matches the video course exactly. If you want to have a book, it's on Kindle and paperback. If you want to see the videos and not miss a day, please click on the subscribe button, and then there's a bell which goes into a dark grey colour, which means it will come higher on your feed so you won't miss out. So that's all I've got to say. We're going to jump into the first lesson. As a reminder, if I mention the old exam or ICND1, it's because it's in the new exam also. Drop a question if you've got any, and best of luck with the course. So welcome to our first presentation. This comes under the ICND1, Network Devices and Diagrams. Cisco have made a few little additions and tweaks to this part of the syllabus for the exam. They originally, in the not the previous but the version before that, were asking wireless questions, but that included security and wireless protocols and troubleshooting. Now they're just asking about the impact of devices like wireless access points and firewalls to your network. So I'll cover the things that they've included as they crop up in various slides. Coming up, common network devices, a few icons later on we'll just look at. So the idea is if we're all using the same kind of iconography for our network topology diagrams, we can all actually understand what the devices are doing. For example, you can see a laptop bottom left connecting to, this is an icon for a layer 2 switch, so it's concerned with frames on the network and not actually routing any traffic. That's connected to a straight line, which normally indicates an Ethernet line to a router, and then the router's going out on a WAN connection as some sort of serial line to a cloud, which is some sort of service provider usually. So we'll look at LAN and WAN layouts also. We're going to be digging into switches in some more detail, great detail actually, as we go through the course. But for now, as far as the CCNA syllabus goes, switches work at layer 2. There's actually a tweak to this when we look at inter-VLAN routing, which we'll cover. The funny thing is you're actually only tested on configuring a layer 2 switch, so it's a bit strange that they've put that in. Now switch can be layer 2 and it can have some layer 3 functions. For example, you can add IP addresses to a switch, and you can add default gateways, this kind of thing, which gives it some very basic layer 3 functionality, which would let you do something like telnet to the switch to manage it or ping it for troubleshooting. It can be a layer 3 router, layer 3 also, which is a router on a switch. Sorry, I've put that on the background of the models of switches there. Basic switch usage. You've got a hub here. This the icon, the blue icon in the middle is a hub, and Cisco don't really cover these in the requirements. However, it kind of helps to work out what a hub does. I think we touch on it later in CSMA CD and why we need a switch in the first place. So a hub basically connects all devices but doesn't segment the network in any way, so they're all vying for attention and using the same bandwidth. Now if you use a switch, you can, if you wish, separate the ports on the switch into different virtual local area networks. So each number of devices here, say there's 10 devices or 8 devices, can all behave as if they're on a separate LAN, even though it's virtually configured inside the switch, and this can apply to your entire network. So it makes it easy to manage, and you can separate the administration of these devices. Alright, so this is a 2960 switch, which is currently what they're tested on in the exam. You've got Ethernet connections here. You can see 24 fast Ethernet, gigabit Ethernet connections, so high speed. You've got management ports where you can actually physically, if you're connected to the device or remotely, there's ways to cable it up so you can remotely connect and carry out management and emergency recovery. You can also connect IP telephony, which they actually do cover briefly in the syllabus as well, configuring IP phones, or not actually configuring the phones, but configuring the switch to allow an IP phone. Alright, main role of a switch, segmenting the network, which we looked at in an earlier slide. Improves your bandwidth usage, so it's just a more intelligent use of the bandwidth available on the ports. You can connect the work group together, you can connect switches to switches and different virtual local area networks. For example, an admin team can be connected to one switch and other people on the admin team can be connected to a different switch physically but still be part of the virtual local area network. You can get high speed, use one of your gigabit ports to connect to a network server, and it will also normally connect to a router at some point. And this is a big overview, by the way. We'll be going into more detail throughout the course. So that's a 29 series router in the background there, and you can see it's got modular interfaces at the back which you unscrew and then screw in various different types of interfaces. You check your documentation to see what's supported. Routers aren't necessarily concerned with end devices, they're more interested in building a directory of networks. They'll give you access to your wide area network or your telco, which is your telecommunications provider. Usually modular nowadays. The early days of Cisco, they were actually welded in onto the motherboard, your wide area connection, any voice modules, and you couldn't swap them out. And if you wanted a particular service, you'd have to buy that model of router. Now Cisco have changed it so you will plug in whichever module you actually want, which is a lot more convenient and less expensive. Cisco make models from a small home office to large enterprise networks, as you can imagine. They don't actually test you on router modules, but it's worth you knowing. This is an example of one of the modules that you will plug into your router. Now you normally have to power them off. Some of these modules are known as what's known as hot swappable, but you must check your documentation first. So that means you don't need to power down your router or switch. You can actually unplug whatever module, say it's broken, or you wanted to upgrade it and swap it out. But again, you must check your documentation, otherwise you could cause electrical shorts and break the device. You can get Ethernet modules as well. Say you wanted a mini switch inside your router for whatever reason. You can get voice modules. This is what's known as a VWIC 1MFT T1/E1. Again, some of these may not be available anymore. Cisco may have changed for whatever reason. You can check online or with your Cisco sales rep if you've got one. Firewalls, Cisco have brought this into the syllabus only briefly, but they're expecting you to have a knowledge of firewalls and what they do. They basically filter and monitor traffic. Now you've got a few choices. They can be placed internet facing. You can put them internally as well between different networks that you want to monitor or filter access for whatever reason. That's pretty common. You can also use them to secure connections to remote office if you want somebody who's either a traveling salesperson or works at home somewhere. You'd want them to connect in through a firewall to be authenticated. Now, this is something I think they may ask, or I thought it was worth bringing up, but firewalls, stateful versus stateless. Stateless treats each packet individually, and these are like the early generation of firewalls. So each packet is treated as an individual entity, which obviously you can imagine if you've got thousands of packets coming in each minute or faster, then this is going to quickly cause a problem and take a lot more processing power and slow down access. So because each packet is individually examined and treated, i.e. there's no flow created, then a new connection, the firewall's got no idea if the packet's from an existing connection, if it's new or rogue, because it's not comparing it to the other packets. So there's no state table built. So stateful inspection, this is the most common today. It's known as fourth generation firewalls. They can operate layers 3, 4 and 5 and probably beyond actually, but you want to go into CCNA security for more details on that. And it tracks what's known as streams, which can be TCP or UDP or other such protocols. Now streams are kept in a state table, and what this allows the firewall to do is build a map of related connections, and it can also speed up traffic that's coming in and out because it recognizes a particular state or a stream that has already been permitted. Then it's safe to assume that the same traffic inside the same stream can be also permitted, and obviously the same applies to denied streams. So this is a picture, I think, from our CCNA study guide of a state table that's been built. You don't really need to know in detail, but I just wanted to show you it's showing the source port, source IP, destination, protocol, and from this information it can build a state table. Security zones are just worth mentioning in brief. The administrator assigns various interfaces on the firewall into zones. Now these zones can be trusted or untrusted. Untrusted would generally be your internet facing zone. Trusted would be different LANs on the inside of your network. External traffic, say for example you have servers that you want internet traffic to connect to, for example your website, say you're managing your own website for your company, you can create what's known as a DMZ, a demilitarized zone, which external traffic could come into without actually hitting your internal network. Alright, a little bit on wireless. The wireless obviously replaces the layer 1 wires and the current layer 2 protocols. Wireless has its own set of protocols for layer 2. The good thing is, which we'll look at in the OSI lectures, the upper layers are not affected. For example, your email and other such traffic isn't affected in the least. The network isn't aware or doesn't care that you're using wireless. There's various 802.11 standards, which I don't think you're expected to know anymore for wireless, because Cisco have created a CCNA wireless now. Alright, collisions, which we cover later for Ethernet. Wireless networks use collision avoidance. Collision detection is used in Ethernet networking, wired networking. For short, it's known as CSMA CD. Carrier sense multiple access with collision avoidance. You have a distributed coordinated function. So this is an algorithm that runs that uses back-off timers. These are in milliseconds, and this is the algorithm that's used to try and prevent collisions on your wireless network.
There's an algorithm that runs for CSMA CD also, but that's different. I'm sure you're aware of service set IDs. Basically, it's the name of the wireless network that you would connect to, and we've all done it either at home or in coffee shops or places like this. So this identifies a logical network. Once you join this particular SSID, other traffic from other SSIDs is ignored. There's something called a extended service set and basic service set. I'm not sure they'll drill you on this in the CCNA. Again, it's moving into CCNA wireless. The wireless access point, which is the wireless device that you connect to over the wireless network, acts as a hub. And there's an extended service set. This is where you've got multiple access points that service the same service set ID. So you could connect to several wireless access points. Speaking of access points, there's a picture of one on the top right there, a Cisco one. Wireless access points, they enable end devices to communicate with your wireless controller. It also authenticates devices. Now all of these functions can actually be passed over to your wireless controller. Say for example you've got several access points, you're working in a factory somewhere and you need to connect to your nearest wireless access point. What they will do is simply provide access to your wireless controller where all your configuration has actually taken place. So this takes over the functions of the access point. At this point your access points become what's known as lightweight access points, LWAPs, and all they do is forward your traffic. So I've already mentioned roaming. Say you've got a signal but you're moving to a different part of the warehouse, you'll connect to another access point because it's got a stronger signal. Now this is from, I think from our Network Plus study guide, but just worth noting you've got a roaming client here, and the left one, the roaming client, is connected to one access controller. On the right it's connected to whichever the closest lightweight access point is, which then connects to the wireless controller. So you've got intra roaming, which is on the left, and then inter roaming, which is on the right there. And then finally just some network diagrams which I'm going to cover quickly. These represent the network which I mentioned at the front. It's an agreed format for all of us to communicate our network topology, which you may need to send to management or to your network provider. Say you've issued a support ticket. Also used in labs and exams. The icon for a router, a layer 2 switch, router with a firewall module, wireless LAN controller, which we've already seen, your lightweight access point, which we saw earlier also, wireless router, a multi-layer switch, or a switch that can do layer 2 or layer 3, so it can route traffic as well as switch layer 2 traffic. The cloud, which could be your service provider usually, and you don't care what's going on in there, PCs and laptop. Serial line will normally have a kink in it and it looks like a lightning bolt. Your Ethernet will be a straight line usually. End user, which is one of your customers or somebody who's working in your office. IP telephony, which Cisco are market leader in. Just a very simple diagram. I think I did this with Visio. You've got two switches on the left connecting, one to a server, one to a host PC, connecting to a firewall, and the firewall is going out to either your telco and a remote user. Topologies, they expect you to know a bit about. You can have a physical topology, which is what you see, and the logical topology, which is what the network actually sees. It may actually be doing something in a different way to what it physically looks like. So common topologies point to point. You've just got one device connected to another device. Quite common on wide area networking, to be honest. That's probably where you're going to see it. Point to multipoint is where several devices terminate on one end device. So here you've got a headquarters router and then some smaller offices on the bottom. You probably won't be asked anything more on this because Cisco have got rid of frame relay, thank goodness, from the syllabus. So you don't have to worry about frame relay or configuring OSPF in ERGRP over frame relay, which used to be horrible. Used in wireless and frame relay. Now, don't presume that the end devices, the bottom three, can connect to the headquarters device, because that may not be the case without further configuration. But again, don't need to worry about that now. Ring is quite an ancient technology. It was fairly popular, though it went out of popularity when I worked at Cisco in around 2002. Token ring. So it's now obsolete, but you can see all traffic is passing in the same direction, and it's a physical ring and logical ring. The ring is actually housed inside a hub that all the device is connected to, and obviously, as you can see there, if there's a break on the cable, the entire network comes down. A bus is the early version of Ethernet, where you had a big thick cable and then smaller cables actually physically pierced with a screw device into the cable and then connected to a network card. Don't see these anymore. So the original Ethernet worked at 10 meg. It was a physical bus and a logical bus. Star is the most common one you'll see today, where various devices plug into a switch and then a switch will plug into another switch and so on. It's a logical bus. It works logically as a bus, but physically when you look at it you'll see a star. And of course you can have a hybrid, which is a bit of one and a bit of the other. Hub and spoke, used in wireless area networks, remote offices connecting to various interfaces on your headquarters router. Full mesh is where you cannot afford any downtime whatsoever, so every device has a connection to every other device. The formula to work it out is n times n minus 1 divided by 2. So you'd add those 4 routers together, 4 times 3 divided by 2, and that would tell you how many connections you need. Costs you a lot of money, obviously. And then you've got a partial mesh, so if 1 or 2 connections down, you've pretty much guaranteed another way for the device to reach the other devices. It just may take a little bit longer. So you've got some redundancy here. Alright, so a lot covered, but nothing too meaty, which is why I covered quite a few different areas, but it's a good way to kick off our CCNA studies. So that's the end. I'll see you on the next slide.
Welcome to the OSI Model presentation. It's a strange area really to chat about for network engineers, especially when we're coming to look at studying for exams. But the OSI is pretty important really for a couple of reasons which I'll come into, but they did test the OSI model quite thoroughly in the Cisco exams up to about 3 or 4 years ago, but then they introduced adaptive testing and also more hands-on practical tests, and Cisco responded to feedback from their customers, which is who they speak to before they set the syllabuses for all the exams, and the OSI has been given less priority. However, you may be asked a question on it, and it does come in handy, as I'll explain as we go on. So coming up really, why is there a model at all? Why is it in your interest to actually learn about the model, and how are we actually going to apply it? Because everything really now for Cisco exams, almost everything I should say, is geared to you making you a good engineer in the real world. Okay, so before we had the OSI, this is in the 70s and 80s, you had a whole bunch of manufacturers doing things their own way, and engineers would sit in offices working for IBM, Microsoft or whoever, Novell, coming up with their own way of communicating across the network, their own cables, their own media, their own speeds, and it wasn't really in their interest, or so they thought at the time, to actually communicate and come up with common standards.
So really, if you went down one particular route with a certain technology, you were stuck with that vendor and you were stuck with their software, which doesn't really work out too well for the customer, because a lot of the time a certain manufacturer will only do one thing particularly well. So they'll only produce a really good model of switch, but their routers aren't so good, and same with software. So the OSI really, well, this is just an illustration really that devices can't really communicate well. So the International Standardization Organization, I think that's what the ISO stands for, created the OSI. So it's not an acronym of their name. It's Open Standards Interconnect. And really it's just an agreed set of protocols or standards for devices to function. And what they did is the OSI didn't tell you how to do it, but they explained the methodology in which it would work. So they laid out a framework, and what they said was each device needs to work at a specific layer. Each layer needs to have a specific function, so it does one thing, but or one type of thing, but it does that thing really well. So 7 layers. Some people get the numbers wrong. Layer 7 is always at the top. It's always the application layer, and then we go down 6, 5, 4, down to 1. Application, presentation, session, transport, network, data link, and physical. The way to remember this is with a mnemonic, and it's all people seem to need data processing. So it's well worth, if you haven't heard that before, writing it down. All people seem to need data processing, and that's how we remember the 7 layers. Right, so now we've got layers. For example, on our network layer, we know our Hewlett-Packard router should be able to communicate with our Cisco router because they're using an agreed set of standards and protocols. Our layer 2 switches from different vendors can also communicate, because think about it, you're not always going to be communicating with inside your own internal network, and perhaps you might have different models of switches in different parts of your network for a whole bunch of different reasons. So data flows, and this is a theoretical model. You can't see data flowing down the OSI model. It doesn't work that way. It's just a concept. It's like a framework that makes things make more sense for us. So data flows down. As it flows down, it's called encapsulation. The data is encapsulated into different formats for that particular layer. And you can see I've written to the far right column the format that the data is called for each layer. It's called data for the first 3 layers, and then they're called segments, packets, frames, and bits. The way to remember this is with another mnemonic, and it's don't some people fry bacon. As data is encapsulated, it goes down through the layers of the OSI. When it hits a physical layer, it's going across the wire. So it's in called bits, binary bits we use to represent it, which is basically electrical signals. It goes across the wire and over to which other device. It could be the PC next to you, or it could be somewhere across the internet, and it gets de-encapsulated as it goes up and reaches whichever layer it's intended for. If it's IP routing information, then it doesn't need to go all the way up all the layers. It could just go up to layers 3 and 4. If it's an email you've sent or some sort of video file to be viewed, then it will go all the way up to the top layer. So really, you can see what's really happening, and to be honest, most people don't care. One PC sends a message across the internet to another PC, and the whole thing works, and they're all happy. It's only as network engineers that we need to get involved. So layered approach, as I've said, each layer does a specific thing, has a specific role, and you don't really need to worry about the other layers as long as you take care of the layer that you're designing this software or hardware for. Alright, so let's start at the layer closest to us. This is what we will see as the user. This is where we're using our applications, our web browsers and email programs and stuff like that. So typical type of protocols would be your web, your email, your simple network management protocol, which basically reports on network faults, usually in a graphical program of some sort. Next layer down, the whole job of the presentation layer is basically to present data to layer 7, which I guess that's why it's called presentation layer. Another good reason, or another easy way to remember it, is we use presentation systems or multimedia systems such as video, graphics, that kind of stuff, and also encryption and decryption and compression takes place at this particular layer. Going down now, the session layer, it kind of sets up the dialogue, the communication between two devices, and this is all happening logically. As I said, you can't actually point to a particular part of the network and say, oh yeah, I can see this session being set up. So it'll link devices, and then it could be an instant messenger chat that's going across the network. It actually sets up the session so this can take place. Protocols or services that use this particular layer, SQL, network file system, RPC, which is remote procedure call. I don't really know anything about that, to be honest. Transport layer, remember this is where your data is chunked down now into smaller units, and these units are called segments for the transport layer. So a virtual circuit, not something you can see, is set up. Normally, after the session takes place, that virtual circuit is actually torn down. And you may have heard of three-way handshake, which is where two devices will communicate. They'll send a synchronization, and acknowledge packet in return, and then an acknowledge packet. This is before the data is actually sent, so they're agreeing that the data is going to be sent, and they can actually set up a dialogue or a session before the data is actually transferred. The way they control the flow of data, you can have a really high-speed connection on one side and a slow connection on the other side. So rather than overwhelm the recipient device, they'll agree on the flow control, how much data is going to be sent. Windowing is how much is sent before there's an actual acknowledgement, and then there's an acknowledgement when a certain amount of data is actually sent. So TCP UDP operates at the transport layer. Network layer is where we'll be involved mainly as a network engineer, network layer and data link layer certainly. So your segments are turned into packets, which is a smaller unit of a segment. It works out the best way to take, but it doesn't actually send the data. I'll go into routing and routed protocols. It works out the best way to get from A to Z. This is also where our IP addressing takes place. Typical exam question is, what layer does the router work at? It's a very simplistic question nowadays, to be honest, but routers work at layer 3. And protocols such as IP, RIP and OSPF work at the network layer. Now, I don't expect you to be able to read this, but basically there's a whole bunch of questions and debates about which protocols work at which layer. And this is a post by a CCIE guy called Paul Stewart, I just found on a forum. And he's arguing for different protocols, saying which layer they should work at, but comparing and contrasting as well. It's all very interesting. I just want to bring you back to the fact that we need to be passing an exam here. So there's no point in getting to the exam and you can't argue the pros and cons and which ports it's using. And they're basically looking for the exam answer. And the exam answer is, I've already shown you which layer the protocols are working at. So don't get yourself confused. If you want to read around it later and learn more stuff and educate yourself more, that's really commendable. Also, let's just remember we need to be passing these exams to get the qualification. Data link layer. So our packets are chopped down into frames even further. The switches we'll be using as an entry-level Cisco engineer normally are all layer 2 stuff, and this we still need addressing for communication on layer 2. So it's our hardware address, and we call it a MAC address, obviously, in networking. Our WAN protocols work here, and the data link layer is actually broken into two smaller layers, the LLC and the MAC layer, and so they can communicate with the layer above and the layer below. And then lastly, it's our physical layer. So this is where our frames are turned into bits, which is digital pulses going a wire. And the reason we use bits is there's only a 1 or a 0 bit, which is on or off. Hubs work at the physical layer, which I don't think people really use hubs anymore. Very, very rare and hard to find. And all our cable specifications. Troubleshooting. depends really on the problem, but often this is we can use the OSI to troubleshoot problems. I recommend you do. You can start at the bottom and work your way up, like is the cable attached, is the data going out on the wire, and work your way up through to the data link layer. Next you can look at is the correct encapsulation on the port, Ethernet speeds, and then you go up to layer 3, correct IP address, subnet mask. Typical kind of exam stuff really is which device works at which layer, the function of each layer, which you need to learn by reviewing this, your book, any study guide you've got, or these lectures, which service or protocol works, and also troubleshooting. They may say there's a certain problem on the network. Is this indicating which layer of the OSI does this indicate is at fault? Okay, that's the end of the lecture. Thanks for watching.
Welcome to the presentation on the TCP model. Okay, so the TCP model, it was created by DARPA or DARPA, whichever way you want to refer to them. Also known as the Department of Defense or the Internet model. TCP really is an alternative viewpoint to the OSI model. Now, annoyingly, Cisco have given this a lot of focus for the new style CCNA exam. It kind of was a secondary subject really that rarely came up in exams, certainly in the last few years. In quite early incarnations of the CCNA, when I first took it in around 2002, it was a very theory-based exam. There was no simulators and very little knowledge of iOS was tested, so it was more heavily tested. But throughout last few years, Cisco referred to TCP and the OSI less and less, and now it seems to have come back with a vengeance. It really describes how data is handled and how protocols interact across an internetwork. So we're going to cover the TCP model and also some typical exam style questions that you may come across. Now, the feeling is that the TCP model is preferred over the OSI model. The confusion comes in the fact that the OSI is a 7-layered model and so gives you more granularity. Each layer's got a specific function, and the TCP model is the same, however you have more functions to fit into less layers, as you'll see in a moment. So the strange thing is that although Cisco like to say that the TCP model is preferred, and I'm sure it is, the OSI model is referred to an awful lot when you're discussing internet working with other engineers and also during troubleshooting. And to confuse things further, traditionally Cisco always referred to the TCP model as a 4-layered model. In the recent incarnation of the exam, they're referring it to it as a 5-layered model. Now, I think you'll need to know both, because just a few months ago, any exam questions were referring to the 4-layered model, and now they're leaning more towards a 5-layered model. Just for your own information, it's always been referred to a 5-layered model and a 4-layered model. When I've had students contact me and complain about exam questions or the way they were asked, Cisco seemed to have switched between 4 or 5-layered model. So the TCP model covers all of the TCP documents which are documented. I think I've already mentioned in requests for comments, which you can do a Google for RFC. And all internetworking functions are broken into various layers. So if you're looking at the 4-layered model, it goes 4 down to 1, application, transport or host-to-host, internetwork, and then the link layer or network interface layer. The 5-layered model basically breaks layer 1 from the 4 model into 2, closely mapped to the OSI really, which is the data link encapsulation, or the physical, which is the bits onto the wire. So that's the only difference really. For the exam, I recommend you know mainly the right hand side, because it's pretty easy to remember the 4-layered if you can remember the 5-layered model. You also need to know which functions map to which layers of the TCP model. the application, the transport, the internetwork, and the link layer. So pause the slide, print out the notes, and commit this to memory. Encapsulation, again, it's the same concept as the OSI. Data, obviously, as it travels down, each particular layer of the TCP model has a respective header added onto it. So the TCP header is added at the transport layer segment, IP header, which is normally your layer 3 addressing, your network addressing, source and destination. Then your data link header frame is added at the data link layer, and then the bits are put onto the wire. As the frame travels across the network, it reaches the other device, and then each layer de-encapsulates the relevant part of the frame. OSI versus TCP, again, something you just need to remember. Luckily, the TCP model maps to the first 3 layers of the OSI. So the top layers are the closest layers to the user, but TCP/IP is more concerned with the transport layer and below, how the actual communication takes place across the internetwork. Typical exam questions, again, just know the layers. It's a little bit of a pain really, but it does come in handy, I find, when you're troubleshooting, just to have it in your head which layer you're going to start at, top down or bottom up. Remember how the OSI maps to the TCP, because they may ask you to compare the layers. And that's the end of the presentation. Pretty straightforward, and I'll see you on the next lecture.
So let's cover network cables and media. All your bread and butter stuff for the exam and also for entry-level engineers. So it can get a bit confusing actually, cables and the wires inside the cables and the pins on the end of the cables and male and female parts and all the terminology. But really for your exam and for most of the real world, in fact, you only really need to know how to connect out to the wide area network or your telco usually. Your Ethernet connections, which are pretty standard, and management. And management really, in this context, I mean how you connect to your router when you're sitting in front of it in the data room or your switch. So Ethernet cables, here's me holding your standard Ethernet cable, the connector on the ends called RJ45. We normally hold it with a little tag on the bottom so we can see the colour of the wires quite easily when we compare them, which I'll show you how to do that in a moment. So generally speaking, we're just using our Ethernet cables to connect our workstations to our switches. Obviously we do connect our switches together as well. Increasingly now we're using optical connections between our switches. Obviously we need to connect our switch to our router, and all our routers have at least one Ethernet port on them. And as I mentioned, the presentation on the end is the RJ45. It uses unshielded twisted pair, so there's 8 cables and each cable is twisted with another colour cable. The reason for this is they found that it didn't necessarily make the signal go further, but it prevented interference. So in theory you can send the cable or have the cable going for a longer distance, if that makes sense, because there's no interference. Crosstalk as well. Crosstalk is where the signal going across one wire interferes with the signal going across the other wire, actually inside the cable itself. Alright, so just a table really showing you the category of cables. It goes further past 6 now, I think there's a category 7, and the application they're used for. So category 1, 2, 3, 4, not really used anymore. Category 5 and above is used mainly for Ethernet networking. Alright, duplex. It's worth understanding or having an appreciation of what duplex is. Really, in networking terms, it's just the way that the information is going across the cable. And it used to be an issue, not really anymore, but half duplex is where the information can only go one direction at a time on the network cable, or even on the segments on the network. So you can only send data to a certain device, and then you'd have to wait, and then it would be received. where nowadays really all Ethernet devices are working at full duplex, which basically means you can send and receive at the same time, or because they're using different cables within the wire. If you're configuring it on a router, and I don't see why you would be, you just go into the Ethernet interface and you can configure the command half-duplex or full-duplex. Okay, speed, Ethernet generally 10 meg is a little bit slow, to be honest, but you can set 10, 100 or auto, which means it auto detects the configuration depending on the device on the other end. In every network engineer role that I've worked, nobody leaves, or nobody should leave, their speed to auto. It can cause problems, and I've seen it cause problems, so it's almost always hard set to 100, for example, if that's the speed you want. I've put an output of a show interface Ethernet or fast Ethernet 0/0 here, which is the number of the interface on this particular router, and it shows you your duplex settings, your speed, keep alives, a lot of interesting stuff, and also your hardware address, your MAC address. And you can see at the bottom there, if there's any problems where you're seeing problems or lots of errors on the interface, you should always really check your duplex settings and your speed settings. Obviously our RJ45 connects to the female connection on our switches, routers, and also if we have network cards all connected to our end user PC. So straight through cable, this is referring to the colour of the wires. Now I've made up just a random colour scheme. There are two set colour schemes for cables, which I don't think we need to worry about for the CCNA exams. But I've put colours and the numbers of the pins of the cables right underneath. So red, yellow, blue, green, cyan, purple, magenta and lilac. But these are just random colours. My point is a straight through cable has one end matching the other end exactly. So if you looked at pin 1 you would see red, pin 2 you'd see yellow on my diagrams here. And it's for connecting your workstations to your switches, or if you need to connect a router to a switch. And as I promised, you just hold the two ends together there and you can see the colours of each of the ends. And the reason is not all network cables are straight through. We do use crossover cables where you'll see pin 1, which is red, goes to pin 3 on the other side, and pin 2 on one end goes to pin 6 on the other end. And this is where usually we're connecting a couple of devices and we don't have a switch between them, and it's for connecting like to like. So if you're going to connect a switch to a switch, a PC to a PC, I'll just go back. So this is where you're connecting like devices, and if for any reason you wanted to connect two routers together as well. Now, a lot of modern switches will auto detect, so they will detect whether or not they should be using a crossover cable, and it will automatically convert your straight to a crossover for you, but you can't always guarantee that. A rollover cable, it's also called a flat cable, console cable. This is the cable we use to connect to the management ports on our switches and routers, and basically every single cable is swapped. So our number 1 is red and on the other side it's number 8. Number 2 is yellow and on the other side it's number 7. So the whole thing's just turned upside down. And typically, not always the case, but most of the console cables you'll buy for Cisco devices, they're blue, but I have seen other colours, so it doesn't always work that way. And you can see the actual cable here is flat, it's just been squashed flat. So the modern rollover, we don't always have, you can see on the right hand side there's a connection going into the back of a PC or a laptop, and it normally goes into a 9-pin connection. But we don't have these built into modern laptops or PCs anymore, to be honest. So you've either got to carry around an old-fashioned laptop or use an adapter, which normally nowadays is a USB adapter. You can see on the left-hand side a console cable, on the right-hand side we've got a USB adapter. You can buy these off eBay or a lot of electrical stores. The only problem is a lot of the time the drivers are quite flaky, so you'll have one type of manufacturer cable and it doesn't work very well, so you buy another cable from a manufacturer and that works better. and I've had all sorts of problems with ports for USB cables and this sort of thing. So the converter cable does come with software, and you can see here we've plugged it in, we've uploaded the drivers, and it's given us COM port 4 for use for our connection. So if I wanted to use a hyperterminal or PuTTY, I would connect on COM port 4 if I was using my USB cable, and not as we often do using COM port 1. WAN cables, there's a whole raft of presentation types and methods for connecting to our internet service provider, so we need to check with them before we buy our equipment what presentation they're going to give us and how we're going to connect. But our standard connection normally requires a DTE end, which is our data terminal equipment, and a DCE, which is our data communication equipment. The DCE end is normally provided by our telco company. The only time we really need to worry about that is if we've got our own rack of equipment at home, where one end will need to act as the ISP. And we can see our standard serial cable. If you do a search on eBay for Cisco serial cables, you'll normally see a DB60. And when you buy them, just check before you buy them actually that one end is the DTE and one end is the DCE. And the reason is we'll need one end as the DCE for our home labs. Okay, presentation types. So we've got a DB60, which is our standard serial cable. On the right here, you can see it's the same protocols, but it's just a different presentation. This is called a smart serial cable, and it's a great space-saving device if we don't have, if we need two connections going out of our router to two different offices for whatever reason, but we've only got space for one modular card. And you can see a WIC 2T with a smart serial presentation on the bottom there. Okay, so that's the end of the presentation. Just a gentle overview. I recommend you have a look at some live equipment if at all possible. If not, have a look at some pictures on Cisco's website.
So welcome to the presentation on CSMA CD. Now this was originally in the CCNA exam a few years ago, in as much as it was a basic networking concept that they wanted you to understand. Then it seemed to kind of fall out of favour because it was a fairly basic topic, and the main secondary reason is that collisions on Ethernet networks are really a non-issue nowadays because we have full duplex networking from our fast Ethernet specifications, so we don't really have collisions unless we add a hub to the network. So for whatever their reasons are, Cisco have reintroduced this into the syllabus now, and you may well get a question on this particular subject, so that's why we're talking about it. Carrier sense multiple access, you can break down the acronym to carrier sense, which basically means the port in question listens to the wire, and it's listening to the wire to see if there's a signal being passed. And multiple access means more than one device. Many devices connect to the backbone. And collision detection, this is where the port in question will check for a damaged frame. Just going back to the multiple access, we do have multiple access technologies that are still covered on the CCNA exam. The main two examples you'll see are Ethernet and frame relay, and they bring their own particular sets of problems, challenges and configuration requirements, especially when we're looking at protocols such as OSPF. But we'll come to that later. So here I've attached an icon just to demonstrate my point to a switch. I think that's a 2950 model maybe, or a 3550. Took a picture and just attached the icon saying that the port is actually listening to a frame on the wire, or to see if there is a frame on the wire, which is indicated by an electronic signal. Now if there is a collision detected on the wire, then a jamming signal is sent by detecting devices which prevents another frame being sent for a set period of time. Now I've put in a flowchart, and the source is from wikipedia.com, and this gives you a good pictorial representation of what's actually happening through the CSMA CD process. Frames assembled is an attempt, and then you have the yes/no switches. Is another station transmitting? Yes, then it just keeps waiting. This happens very quickly in milliseconds. If there is no device transmitting, then it can transmit the first bit of the frame, and then we go into the collision detection part. Now I've numbered the wires that you'll see on most category 5 and above cables from 1 to 8. These aren't the correct, I haven't put the correct send and receive channels with the correct cables, so I just wanted to illustrate the point of why collisions aren't possible with full duplex mode. It's because wires are given specific purposes now, 2 for send, 2 for receive, and then we've got other specifications, other requirements for other pins on the cable. But you can see if all a particular wire has been used for is sending and not receiving, then there can't be a collision. Now you will see collisions when you're connecting the wires to a half duplex device, such as an old-fashioned hub or some old-fashioned type of networking card. Duplex, I think I've mentioned elsewhere, but I'll cover it here. It just refers in networking parlance into which way the information is going. Half duplex is one direction at a time, and the kind of an analogy really is a walkie-talkie. If you've ever used one of those, there's only one channel, and both people can't speak at the same time. One has to speak. They normally indicate the end of their particular transmission by saying the word over, and then that means the other party can transmit. Full duplex, both directions can be used at the same time. So depending on what the context is, it could be 2 channels, or in our networking it can be 2 or 4 sets of wires. You must also try out the command and know the command for the exam, but try it out on a live router or on a packet tracer or GNS3, whatever you're using. And you'd be expected to know that for the exam. The other topic which is related to this is collision domains. Big exam topic, and particularly they want to know how far a damaged frame has travelled and knowing where the limitations of a broadcast domain are. So I've created a diagram here with a switch in the middle, and the switch is connected to networking hubs. As I'm sure you already know, a hub is a dumb device. Mostly they work in half duplex, and all they really are is a multi-port repeater. Now the switch, because it's each port on a switch is its own collision domain, any collided frames that come from either hubs will stop at the particular port that it's connected to on the switch. So in this particular example, we have 2 collision domains. Now, a very common exam question, and one that you can easily be caught out on when you're under pressure in the exam and you can see the clock ticking away and you get excited because you've seen a question to which you know the answer. It's very easy to click on the wrong answer. A switch increases the number of collision domains. You may, in haste, click on the wrong answer, and Cisco will always add the decreases the number of collision domains as one of your options. Trying to catch you out nastily and hoping you'll click on the wrong one. So a switch, every single port on a switch is its own collision domain, and so it increases the number of collision domains. And you may well see a network topology diagram just like this one. And what Cisco will want you to do is answer the question, how many collision domains are there and how many broadcast domains? Now remember, switches will break up collision domains. They can't break up broadcast domains. They're not designed for that purpose. So I've labelled each port on a switch, connecting switches or switches to routers, as its own collision domain. Put a circle around it, and I've numbered it in red so you can see how many collision domains we have in total, which, counting up here, looks like we've got 8. Now I've highlighted the broadcast domains in green and put the numbers in green as well, 1, 2 and 3. Only a router, and in particular an interface on a router, will break up collision domains. So very important point, you must understand this and get this right for the exam as well. Okay, so that's the end of the presentation on CSMA CD. Thanks for watching.
Welcome to the beginner's tool for Cisco Packet Tracer. Quickest way to find the download link is to just Google Cisco Packet Tracer and you'll get to Cisco Network Academy, who host the software, all the instructions. They actually give you a training course, like a beginner's introduction, also various features such as Internet of Things, so well worth taking those courses also. This is just a quick get you started and give you a familiarization tour of the packet tracer. So you'll click on the link. Now you'll need to open an account. It's free to get an account with Cisco.com and Cisco Network Academy. That gives you access to the software and also all of their tutorials, and there's lots of other goodies that you can look at in your own time. So you'll enroll. If you've already done that, as I have, you can just log in then to the Cisco Network Academy. You don't get access to the Network Academy training courses unless you're a member of Cisco Network Academy and taking their CCNA or CCNP courses. Now once you've logged in, you'll be able to access the software and all of the download instructions. Obviously read the download instructions and find out which is the correct version that you'll need for your software version, and also if you're running a 64-bit or 32-bit version of Windows. I'll skip the download because I'm sure you're familiar with how to click on software and how to download it, and further down here you can see the information about the Packet Tracer beginners courses, and I'm sure there's some other stuff there that they'll offer to sell you if you're interested in doing any paid training. So I've downloaded the software, and every time you start it from your desktop, you'll be required to log in. You'll use the same account, password and login that you had for your download. Alright, so this is the canvas here. This is the area where you're going to be dragging any devices. You can click on a logical or physical. You'll normally spend most of your time on logical. And as with most software, you've got a menu with various options at the top here. We're only going to go into a couple of these options. You can go through those in your own time. Now down the bottom you'll see various icons, and each one you click on will give you a different selection of devices. For example, I'm on the routers and switches, and I can click on any of those for desktop PCs, for cables, your folders, types of WAN connections like frame relay. And as you click on each one, you've got a subset of devices that you can also click on. You're going to spend probably most of your time up here on the routers and switches. This gives you access to the router, switches, hubs and wireless devices. Look at any device that you fancy and then you can drag it onto the canvas here. It has the device name and the model also. This says 1941, which is the model of Cisco router. Now if I go up to options and then preferences, I can actually tick what I'd rather be shown. For example, if I do or don't want the device names or the model labels, I can tick off. There's no save button, strangely enough, so you'll quit out of it. And you can see the model number has now disappeared. I personally like to keep it on. You choose whichever is right for you, but I like to know what devices I'm configuring. Sometimes if you've got lots of devices, the desktop can get a bit messy. Now when you click on it, you will see a physical version of the device as if you actually had it at home, and you can see I've got some blank slots here. I've got some ports for connecting Ethernet and gigabit modules and connectors. Now I've dragged up a different device, another Cisco device, but a different model. These will all look at the Cisco website if you want to see what they all do and what they're all for. You can see this actually has blank slots. So this is a modular router that you need to decide what type of modules you want. I've turned the power off by flicking the button or pressing it, and you can see you'll click on any of these modules and you can actually drag them straight to the desktop, Whatever you click on appears in the bottom right also, and you can drag the icon of the device over to the correct slot. It will only fit in the slot it's designed for, so the last slot here, the fast Ethernet module, wouldn't fit into the one before, wrong size, and it's not designed to support that particular module. Now you can click on config and you can do some basic configuration if you so wish. I don't recommend you use that particular facility. It's quite basic and you can't do much. I've changed the display name to HQ router. You've got interface, device, type of routing you can configure, a whole bunch of stuff there. And you can also change the IP address and subnet mask. This is handy for devices that have no configuration capability. For example, if you're configuring an IP address on a lamp for the Internet of Things. That's covered in the 101 Network Plus Labs. Alright, so you can see there's a configuration being applied even though I didn't go into the router command line interface, it just did it through the options box at the top. So I've got the physical view of my device here. I'll just move it so we can get a nice view. If you go to options and preferences at the top, you can change a few things. One of the things you may want to change to suit your particular taste and how your eyesight is. Obviously, some of us can see better than others. You can make the font larger size and you can change the font type also. So I've changed it to Korean New. I'm going to change the iOS background to green. It won't look very nice, but I just wanted to demonstrate how you do it. Quit out that window, and then when you click on the CLI, which is the command line interface, you can see it's very bright green with a black background. I don't particularly like this. I'm sure you don't either. So we'll just take that back to the default, which is a white background with black text. So I'll just resize my command line window. And what we'll do is connect our devices together. You can see the lightning arrow here. It gives you all your cable options. You can automatically choose. You can see down the right it changes as you hover over each cable. And you, from whatever theory book you've read, need to know which cable to plug in. I'm going to use a clock rate on this left-hand side. So this would be my internet service provider. And on the right, I will have it as my office router that doesn't have a clock rate. So to get rid of the clock, the cable device connector there, I've pressed escape. And what I want to do is connect a WAN module to my router so I can connect a serial cable. So I'll choose the WIC2T here. And I'll just drag it. Which slot you drag it into is your choice. Depending on which slot you choose, it will have a different name. For example, serial 0/1 or serial 1/0. You can read Cisco's sales website for more information on that, or read any Cisco study guide. If you hover your mouse over the device, you can see what the interfaces are, the IP addresses if you have any, the IPv6 addresses, and if the interfaces are up or down. So I'll go back to the cables and click on the clocked for the left, and I'll connect it to the serial end on the other side. If I tried to connect it to the serial, the fast Ethernet, I'd get an error. And you can see the little clock has appeared there. That means I need to add a clock rate to this side. I've just dragged up a layer 3 switch just to show you that it's a completely different physical view, and you can zoom in to see more information. We won't be using that at the moment. I can click on the little X up here and I'll just click no, but anything I click on now I can delete off the canvas. And then I've clicked back on the arrow on the far left. I'll drag up a switch, a 2960 from the canvas down here, and then as I go across I'm looking for the correct cable type. For example, this is a straight through cable, and I know from reading my study guides that this is the type of cable I want to connect a switch to a router. There's some end devices here. I'm going to choose a generic PC, and again I'll use a straight through cable to connect the PC through the fast Ethernet port to the fast Ethernet on my switch. You've got a physical view here. You can't actually see where the cable's connected on the diagram. It's just a physical representation of what it would look like if you had one locally. So I've clicked on the command line for my router here, the 1900 model. Initial configuration, you will always type no here, otherwise you're left with a menu of yes or no and enter various answers to questions and the router won't work properly. The first thing is I'll hit a question mark to see what my available commands are, and you can see there's not many here, so this means I'm in quite a limited mode. So I want to get out of this mode, and the command I will type is enable. That gets me from user mode to what's known as privilege mode, and I hit the question mark. If I want to scroll to the next line, I'll just press the space bar, and there's a whole bunch of commands here, and you can see the command has changed from a greater than sign to a pound key. I'm going to use a show command here, then I'll hit the question mark again, and you see because there's quite a lot of options here, I get the more sign at the bottom, which means I can press the enter key or the space bar to see the next page. If I don't want to see any more, I'll just press the Q key. Now I've typed the letter V and hit question mark, and it's showing me every command that starts with the letter V. I can type out the one I want, or I can just type out some of the letters, hit the tab key, and it will finish off typing the command for me. It will do that if there's only one option that fits those particular letters that you've typed. I've issued show version, which tells me the software I'm running, the version, how much memory I have installed, when it was last reloaded and how, the license information. A lot of useful information here, and also the configuration register, which you'll cover if you're doing any CCNA level labs. Alright, config T, configure terminal means I'm going to do some configuration. I can type conf T for short. You can shorten all of the commands as long as it's the only available option for those shortened letters that you're using. Press enter. With the question mark, you can see all my options, and the router's changed to config mode. I'm going to try and configure an interface now, so I'll type interface space question mark. Now I've got a lot of interfaces, but as you know, we've only got a cable connected to a particular interface. I know it's a serial interface, and I actually saw the name appear when I hovered my mouse over the device. To get out of the mode, you can type exit and it drops you back the next level. If you just want to get to the pound sign again, you type end. If I type show IP interface brief, it tells me all my available interfaces connected, if they're up or down, if there's an IP address, and some very basic layer 1 and 2 information. Now if I issue the show controllers command, it will tell me what type of cable I have connected. So I've issued show controllers serial 0/0/0. This says DCE. This basically means it's a clocking end to the cable, and I need to add a clock rate in order to synchronize the connection between this device and the other end. So interface serial 0/0, clock space rate, these are all my options. I'll just choose one of them. It doesn't matter because it doesn't actually affect the speed of the link, it's just the clocking of the link. Now I'm going to enter the IP address because I'm in config-IF, which means config interface mode. You need to type out the IP address, and I'll choose a simple one. And you need to add a subnet mask, 255.255.255.0. The no shutdown command is basically telling the interface to come up, it's to open up so it can pass traffic. Without that command, the interface will stay down. I'll change the host name. I typed exit to drop back down one mode, and I typed host name R1, and as you can see at the prompt, it changed from router to R1. So I've configured one side of the connection. I'll go over to the other side now, and I'll do the same thing, but I just need to miss off the clock rate command, because this side of the connection, it's as if you're in a commercial office and you've installed a router and you're connecting to your internet service provider who's at the other side issuing the clock rate. Interface S0/0, and I know that's the available option because I can hover over the device, or I can type show IP interface brief at the router #. So I'm going to add the other address. It can't be the same address as the other side, so I'm just going to add the next one available in the subnet, 192.168.1.2, and I'll issue the no shut command. That's short for no shutdown, and that's saying now the interface has come up. I just tried a command here, but it doesn't work on Packet Tracer. You'll find it only really supports about 70% of commands you can use on live equipment. The show history command shows you the last 10 commands that you've entered. I've only entered 3 here, so you can see I hit the up arrow, down arrow, and I can scroll through all the commands. So this will save you time. If you have to type out a command that you typed just a few minutes ago or seconds, you just hit the up arrow. Show IP interface brief shows me my interface numbers. I actually clicked on one earlier in the menu system during the demonstration. So I'll go into interface F1/0, which is short for Fast Ethernet 1/0. I'll type no IP address, which basically deletes the IP address off that interface. I wanted to do that because it's the IP address on the other side. The host name is now R2. That makes it easier for me to remember which device I'm configuring at this particular time. And then I'll ping 192.168.1.1. And this sends 5 ping packets, and I've got 5 responses. You can see with the 5 exclamation marks, and it says 100%. This is a very common command you'll be issuing on your network devices. Show start-config shows you what's in your memory on your router, your memory that retains all the information. Now if I issue the show run, this is in RAM, DRAM, so this is the live running configuration. If I want to save the running configuration into memory so it's stored, I'll issue the copy running-config space startup-config. I could issue copy run space start for short. Now if I issue the show start command, you can see my running config has been saved. So if I reboot the router now, it will boot with the IP addresses and any other configuration I've added. Now if you click on simulation mode, what this does, it shows you traffic crossing your network real time, and you can check all the protocols and services available in Packet Tracer. They add more as time goes on. Now you can edit the filters, so you can see ARP traffic, OSPF, RIP. We'll just do a quick demonstration with ICMP. You can tick or untick the protocols as you need them. So I've got ICMP ticked. What I'll do is I'll go in and issue a ping from one side to the other, and it will not start sending the ping packets until I press the little play button, as you'll see in a moment. So I'm over on the right hand side router, the HQ router. Sorry, I don't want to be in config mode, so I'll type exit. I'll type ping 192.168.1.1, press enter, but I haven't got a reply at the moment. That's because I'm in simulation mode, and you can see the little envelope there for the simulator that represents the packet, and then you can see the ping packet is sent, and then returned, a reply is returned. Over on the right you can double click any of the packets. It's all showing ICMP because that's all we ticked on to do our check-in. And you can look at the various layers. of the packet through the OSI model. There's a little tick you saw in the envelope there just for a second, means it was successfully sent and received. Alright, so that's just a quick look at the simulation mode. I'm going to drag up a server from end devices, and then on the cables we'll connect the fast Ethernet to the first available port on our switch. Now I've clicked on the server and you get a different set of options. You get all the physical changes that you can make. You can also click on your Ethernet interface and other settings and add IP addresses. Services you probably won't need to worry about too much until you're doing labs for HTTP, and this server can act as a DHCP server, TFTP, DNS. You can turn it on or off and then enter your DNS records. Syslog, security, network time, email, and you can see all the options here. Now depending on which lab you're doing and what you're trying to test, you will turn on or off different services. On the desktop you've got a bunch of different options there that you can do, for example command line. I'm going to go over to the PC and click on desktop. Here you'll do wireless configuration, a text editor, firewall settings. I'll just click on a command prompt and it will open up a Windows style command prompt in a moment. Typical command you would use, for example, is ipconfig or ipconfig /all. So our network's slowly growing, and as you get more confident, I'm sure you'll add more devices and do more testing. On end devices, I've just clicked down home at the bottom and you can see a bunch of different Internet of Things devices. There's a smart city which has a different set of options, industrial, and you can have card readers, speakers. I'll drag up a passive infrared motion detector and I'll drag up a lamp as well. If you've got 101 Network Plus labs, we show you how to program all this stuff using the Internet of Things. Now these devices can actually connect to your switch, so I'll click on cables and a straight through cable and I'll just connect it to the switch there. All these things can be programmed to come on or off and take various actions depending on how you code it all. Down here under end devices, or under network devices, sorry, you've got a load of different wireless devices. You can have access points, wireless LAN controllers, cell towers, home gateways. I'll drag up a access point and then we can connect it to our switch as if we were installing one at work. So I'll just click on the port and connect it to a free port. Now you can configure all of the devices with your SSIDs and passwords and authentication. I'll just drag up under wireless devices a wireless tablet, and then in a moment you'll see it connect to the access point with a wireless connection. Again, all this can be configured with a whole bunch of different parameters, and finally you can save your entire network, give it a name as a packet tracer file, and then come back to it later. So this has just been a real quick introduction for beginners. I hope to see you on our website. It's 101labs.net, or check out some of our books on Amazon. Thanks for listening.